So this is an example of applying Bayes' theorem in total probability. So I'm going to go ahead and read this problem. Suppose 3 students, Joe, 2, and Marissa, have collaborated on a computer program. Joe contributed 50% of the lines of code, 2 contributed 30%, and Marissa contributed 20%. Further, suppose the percent of lines with errors is 3% for Joe, 5% for 2, and 1% for Marissa. Part A, what is the total percent of lines of code with errors? Part B, suppose a line of code has an error. What's the probability that 2 wrote it? So let's go ahead and start on part A. And in this problem, we can think of this computer program as being partitioned into lines, and they're lines written by one of these 3 people. So there are the lines that are written by Joe, the lines written by 2. Actually, Joe wrote a lot more lines, so we make his part bigger. They're the portion written by 2 and the portion written by Marissa. Within any one of these sets of lines of codes, there are errors. So we have this event, I'm going to call it E, which is that we have a line of code with an error. So E is the error in a line of code. So we know within each person's part what the probability of an error is. So for example, we know that the probability of an error, given that the code was written by Joe, is 0.03. So 3% of the lines of code written by Joe are errors. And we also know the probability of an error, given that the code was written by 2, is 0.05, and the probability of an error, given that the code was written by Marissa, is 0.01. So we know within each of these groups, whether it's Joe, 2, or Marissa, we know within each of those groups what the probability of an error is, but we want to know if we pick out of the whole program, we don't know who wrote it, what's the total probability of an error or the unconditional probability of an error. So we're going to use Bayes' theorem for this. So the probability of an error is going to be composed of 3 pieces. It's the probability of an error, the line has an error and it was written by Joe, plus the second piece is the part of error, lines of code that have errors that are written by 2. So it's the probability of an error n being written by 2. And finally, the probability of error n being written by Marissa. So that's this last little piece. Those are all disjoint, so we can add the probabilities. So this is just total probability. We're breaking it down here. I'm going to use the multiplication rule now. And it's actually easier to write this as Joe intersect error because this becomes the probability it was written by Joe times the probability it has an error given it was written by Joe. Okay, if you had done it the other way, we'd have probability of error times the probability of Joe given error, and Joe given error is not something we know. The next one is the probability is written by 2 times the probability of error given written by 2 plus the probability is written by Marissa times the probability of an error given it was written by Marissa. So now we can just plug in the things that we know. We know that Joe wrote 50% of the code, so the probability that a random line of code was written by Joe is 0.50. The probability of an error, given it was written by Joe, is 0.03. That's over here. Probability 2 wrote the line of code is 0.30. Up here, 2 contributed 30%, times the probability of an error, given that 2 wrote it, that was 0.05. And then the probability Marissa wrote the line of code, she wrote 20%, so that's 0.20. And the probability of an error, given that Marissa wrote the line of code, is 0.01. Okay, so if we go ahead and multiply those all together, we're going to get so it ends up being 0.032 is the total probability of an error. For part B, we want to know if we pick a line of code and we know it has an error, what's the probability 2 wrote it? So the probability 2 wrote it given that this line of code has an error. I should probably have said it was a randomly selected. Okay, so randomly selected line of code has an error. What's the probability that 2 wrote it? So the probability that 2 wrote it, given that it has an error, is the probability that 2 wrote it and it has an error, divided by the probability that line of code has an error. We already figured out the probability the line of code has an error in the last part, so I could just plug in the 0.032 into the denominator. For the numerator, I can use Bayes' rule or the multiplication rule, and I'm going to rewrite it as the probability that 2 wrote the line of code times the probability of an error given that 2 wrote the line of code. And I can figure that out now. The probability 2 wrote the line of code, he wrote 30% of the lines of code, so that's 0.30, and his error rate was 0.05. And so if you actually divide that out, we're going to get 0.3 times 0.05 on the top, which is 0.015 over 0.032. And that is 0.469. It's approximately 0.47. So given that you know it has an error, there's a 0.7 probability that 2 wrote that line of code.